there's a problem with Mercury. According to the latest insider information, the James Webb Space Telescope has found evidence of past life on this intriguing planet. But that's not all. Mercury may turn out to be something completely different than we previously thought, and could potentially hold secrets that were right before our eyes. Studying Mercury is considered extremely difficult and dangerous, and for good reason. At the center of our solar system lies a planet that rarely gets noticed. Recent observations using the James Webb Space Telescope have scientists suspecting that Mercury holds a secret they've been hiding for some time. Mercury is a rocky planet slightly larger than Pluto and much smaller than Earth or Mars. It was originally thought that the world would be too hot to support life or plants. But researchers have discovered water reserves on Mercury that could dramatically change our perception of Earth, and perhaps prompt a complete reevaluation of our solar system. Surprisingly, Mercury is not as hot as you might expect. You might think that this little planet would be the hottest thing in the solar system. In theory, it should be an oven. But that's not true. Mercury, the closest planet to the Sun at just 58 million kilometers, 38 million miles, away compared to Earth's 150 million kilometers, 90 million miles, is not the hottest. Instead, that title goes to Venus. Mercury's atmosphere is hot, but comparatively mild compared to Venus. Due to its proximity to the Sun, Mercury is the fastest planet, hurtling through space at an incredible 47 kilometers per second, completing a full orbit in just 88 days. This speed can probably be explained by the gravitational influence of the Sun. Mercury's surface is a diverse landscape with numerous craters that tell the story of its remarkable past and geological activity similar to Earth's. Notable structures include the Caloris Basin, which is over 1,500 kilometers in diameter and gives Mercury a striking visual effect. Between the craters are vast plains, probably formed by ancient volcanic activity, and in some areas, signs of compression suggest that the planet has cooled over time. Steep cliffs and towering hills, called spur slopes, stretch for hundreds of kilometers and reach up to 3 kilometers high. Other typical features of Mercury include craters, small, bright depressions created by the sublimation of elements such as sulfur and potassium. At Mercury's poles are permanently shadowed craters that remain cold enough to store ice. Scientists have long believed that Mercury is too warm to hold water, so the discovery is something of a minor miracle. When we look at the actual temperature of Mercury, it quickly becomes clear that we are exploring extreme regions. Mercury is not an exceptionally hot and hellish world like Venus. During the day, the highest temperature is about 427 degrees Celsius, but at night, it drops to minus 173 degrees Celsius. Researchers believe that these extreme values are due to the planet's almost complete lack of an atmosphere to retain or distribute heat. In contrast, Venus boasts one of the thickest atmospheres in the solar system, formed by a thick blanket of carbon dioxide that raises the temperature to a whopping 467 degrees Celsius. Mercury exploration has a rich history. It may seem surprising, but we have had accurate maps of the planet's surface since 1974. Images taken by the Mariner 10 spacecraft provided unprecedented views, revealing cratered terrain and geological diversity. Mariner 10 flew by Mercury 3 times, collecting vital data on the planet's surface composition and atmospheric conditions. But there has been a significant gap in Mercury exploration since that first mission. NASA has had significant difficulties sending additional missions to Mercury due to the extreme conditions near the Sun, where strong gravity and harsh thermal conditions pose serious obstacles. It wasn't until 2004 that NASA launched the Messenger mission to conduct a comprehensive study of Mercury. The mission was designed to orbit the planet and collect detailed information about its surface, magnetic field, atmosphere, and internal structure. Messenger successfully entered Mercury's orbit in 2011, marking a major milestone in planetary exploration. The spacecraft has provided groundbreaking insights into Mercury's geologic history and surface features, revealing evidence of volcanism and the ancient tectonic processes that shaped the planet. One of Messenger's most notable discoveries was the presence of volatile elements such as potassium, sulfur, and sodium on Mercury. These contribute to the exosphere, a thin layer of gas that escapes from the planet's surface. The mission provided valuable data on how these elements interact with the solar wind and radiation over time to shape Mercury's environment. Following the success of MESSENGER, interest in Mercury exploration exploded as scientists realized the importance of studying the planet to better understand the formation and evolution of rocky planets like Earth. In 2018, NASA's Parker Solar Probe mission, which focused primarily on studying the Sun, provided an additional opportunity to observe Mercury. The spacecraft's close approach to the Sun allowed scientists to study the interaction between the solar wind and Mercury's magnetosphere, expanding our knowledge of space weather and its effects on the planet's environment. In the future, the James Webb Space Telescope promises to revolutionize our understanding of Mercury and the other planets in our solar system. With its advanced imaging capabilities, JWST will allow scientists to analyze the composition of Mercury's surface in unprecedented detail. By observing Mercury as it transits the Sun, JWST will assess the planet's atmosphere and surface features, providing new insights into geological processes and the potential for it to contain water or other volatiles. JWST's discoveries could transform our understanding of Mercury's formation and evolution, shedding light on its dynamic history and potential habitability. By comparing Mercury's properties to those of other rocky planets, such as Venus and Mars, scientists hope to uncover universal principles that govern planetary development and the conditions necessary for life. In conclusion, Mercury remains an intriguing and mysterious world in our solar system. Despite the harsh conditions and difficulties of exploration, its secrets continue to be revealed through ongoing missions and technological advancements. From the ancient observations of early astronomers to the cutting-edge discoveries of modern space missions, the story of Mercury reflects humanity's ongoing curiosity and desire for knowledge of our celestial neighbor. The study of Mercury has been invaluable in improving our understanding of planetary formation and evolution, and Mercury's unique geological features, along with its proximity to the Sun, provide clues to the early conditions and processes of our solar system. One of Mercury's most striking features is the Caloris Basin, a massive impact crater measuring over 1,500 kilometers in diameter, created by a massive collision billions of years ago. This pool shows the planet's turbulent history and the intensity of celestial collisions in the early days of the solar system. Around the Caloris Basin are vast plains formed by volcanic eruptions, indicating that Mercury was once geologically active. The presence of steep cliffs, called escarpments, on Mercury's surface also tells a story of compression and cooling. These lobed shelves are thought to have formed as Mercury's interior cooled and its crust shrank and split, providing insight into the evolution of Mercury and other rocky planets over time. Mercury's thin atmosphere, or exosphere, is another area of scientific interest. Mercury's exosphere, composed primarily of helium, hydrogen, and trace amounts of other gases, is constantly replenished by solar winds and volatile elements released from the surface. Understanding the dynamics of this exosphere helps scientists study the planet's interactions with its solar environment and its effects on surface conditions. Mercury's extreme temperatures pose a serious challenge to potential exploration missions. Daytime temperatures can soar to about 427 degrees Celsius (800 degrees Fahrenheit), hot enough to melt some metals, while nighttime temperatures can drop to about -173 degrees Celsius (280 degrees Fahrenheit) in shaded areas. These extreme temperatures require innovative spacecraft designs and thermal protection systems that can withstand the harsh conditions near the Sun. Studies of Mercury's polar regions have yielded unexpected results about the planet's potential for water ice. Despite its close proximity to the Sun and its hot surface temperature, Mercury consistently hides craters near its poles where ice could theoretically exist. The discovery of ice challenges previous assumptions about the planet's surface conditions and raises intriguing questions about the origin and history of water in the solar system's interior. Geologic activity observed on Mercury, including volcanic eruptions and tectonic movements, suggests that Mercury was once more geologically active than it is today. Evidence of past volcanism suggests that Mercury's interior may have once been molten, producing explosions similar to those seen on Earth and Mars. Understanding the timing and duration of these geologic processes provides valuable information about Mercury's thermal history and internal dynamics. In addition to its scientific importance, Mercury has cultural and historical significance. As one of the 5 planets visible to the naked eye from Earth, ancient civilizations observed its movement across the sky and incorporated its appearance into their myths and calendars. The Greeks and Romans named the planet after their messenger gods, Hermes and Mercury, respectively, reflecting its rapid movement across the sky. Modern observations and space missions have transformed our understanding of Mercury from a distant point of light to a dynamic and complex world. Technological advances in spacecraft design and equipment have allowed scientists to study Mercury's surface in unprecedented detail, revealing a planet with a rich geological history and unique properties. Future missions to Mercury, such as the European Space Agency's Bepi-Colombo mission, aim to study and understand the planet's composition, magnetic field, and geological features in greater depth. Launched in 2018, Bepi-Colombo is a joint mission between ESA and the Japan Aerospace Exploration Agency, JAXA, designed to study Mercury's surface and internal structure using a suite of advanced instruments. Bepi-Colombo consists of 2 spacecraft, the Mercury Planetary Orbiter, MPO, and the Mercury Magnetospheric Orbiter, MMO. Together, these spacecraft will study Mercury's surface, atmosphere, and magnetosphere, providing additional data that will enhance our understanding of the planet's formation and evolution. In conclusion, Mercury is still cutting-edge scientific research that provides insight into the fundamental processes that form rocky planets. From ancient volcanic plains to mysterious polar ice deposits, Mercury's unique properties continue to fascinate scientists and inspire wonders about the early history of the solar system. Exploring Mercury is not only a quest for knowledge about the Mercury world, but also a journey to uncover mysteries about our planet's origins and the broader history of the universe.